Hello, Mr. Bandana. My name is Anton Earl Elim. I'm here to discuss the Thermodynamics 2 problem, steam table application. So, the question number 20, find the specific volume enthalpy of internal energy of wet steam at 18 bar, dryness fraction of 0.85. So, the givens, the pressure of steam, the pressure is equals to 18 bar, or you can convert it into kilopascal, it in 1800 kilopascal or 1.8 megapascal. So the dryness fraction, or X, is equals to 0.85. So based on the given in the steam tables, I will flash in the screen. The corresponding to 18 bar is the following. The enthalpy of saturated liquid is 884.6 kilojoules per kilogram. The enthalpy of change of vaporization HFG is equals to 19,103.3 kilojoules per kilogram. The volume of saturated vapor is 0.110 cubic meter per kilogram. The internal energy of saturated liquid UF is equals to 883 kilojoules per kilogram. The internal energy of saturated vapor is equals to 2,598 kilojoules per kilogram. So, solving for specific volume, so volume is equals to X, the steam quality, and times Vg, or the volume of saturated vapor. So substitute the given values. So 0.85 times 0.110 cubic meter per kilogram is equals to 0.0935 cubic meter per kilogram. So solving for the specific enthalpy of wet steam, we can use the equation H, or enthalpy is equals to enthalpy HF, or enthalpy of saturated liquid, times plus X times the enthalpy of change of vaporization. So substitute the given values. So 884.6 kilojoules per kilogram plus 0.85 times 1910.3 kilojoules per kilogram. So the enthalpy, the specific enthalpy would be 2508.35 kilojoules per kilogram. So solving for the internal energy, so we can use the equation internal energy is equals to parenthesis 1 minus x parenthesis the internal energy of saturated liquid plus the x times the internal energy of the saturated vapor, or UG. So equals, substitute the given values, 1 minus 0.85 times 883 kilojoules per kilogram plus 0.85 times 2,598 kilojoules per kilogram. So the answer would be 2,340.75 kilojoules per kilogram. So we're done with that, the problem number 20. So we are here for problem number 21. So find the dryness fraction, specific volume, and internal energy of the steam at 7 bar, and enthalpy of 2550 kilojoules per kilogram. So the given would be the pressure is in 7 bar, or we can convert it in kilopascal, 700 kilopascal. The enthalpy of the steam is in 2550 kilojoules per kilogram. So based on the steam table, the given values in 7 bar pressure is the enthalpy of the saturated liquid HF is equals to 697.1 kilojoules per kilogram. So the enthalpy of change of vaporization HFG is equals to 2604.9 kilojoules per kilogram. So the VG, volume of saturated vapor, is equals to 0.273 cubic meters per kilogram. And the internal energy of saturated liquid UF is equals to 696 kilojoules per kilogram. The UG of, or the internal energy of saturated vapor, is equals to 2573 kilojoules per kilogram. So solving for the dryness fraction of X, the steam is in wet vapor, we can use this equation. The enthalpy is equals to enthalpy of saturated liquid plus the X and the enthalpy of change of vaporization HFG. So substitute the given values. 2550 is equals to 697.1 plus the X times 2064.9. So transpose. So we are finding the X. X equals to 2550 minus 697 697.1 over 2064.9. So the answer would be 0.897. The X would be 0.897. So we can now solve for the volume, specific volume. So specific volume is equals to X times Vg, or the volume of saturated vapor. So substitute the given values. 0.897 times 0.273. So the specific volume would be 0.2449 cubic meter per kilogram. So for the specific internal energy, so we can use this equation. Internal energy is equals to 1 minus X parenthesis the internal energy of saturated liquid plus the X times the internal energy, or UG, of the saturated vapor. So substitute the given values. 1 minus 0.897 parenthesis times 696 plus 0.897 times 2573. So the specific internal energy would be 2379.67 kilojoules per kilogram. So I'm done with the question number 21. So we're here in question number 22. So the steam at 120 bar has a specific volume of 0.01721 cubic meter per kilogram. Find that temperature of enthalpy and the internal energy. Givens are the pressure is equals to 120 bar, or in kilopascal 12,000 kilopascal, or in megapascal is in 12 megapascal. So the volume also 0.01721 cubic meter per kilogram. So from the table of superheated tables, at 120 bar or 12,000 kilopascal, the specific volume is 0.01721 cubic meter per kilogram at this temperature of 350 degrees Celsius. And the enthalpy of this, based on the steam table, the specific enthalpy at 120 bar in 350 degrees Celsius is the enthalpy is equals to 2847.7 kilojoules per kilogram. So solving for internal energy. So internal energy is equals to enthalpy minus the pressure and volume. So substitute the given values. 2847.7 minus parenthesis 12 the pressure in kilopascal, 12,000 kilopascal times 0.01721. So the answer, the internal energy would be 2,641.18 kilojoules per kilogram. So I'm done with the question number 22. So let's go with the question number 23. The steam at 140 bar has an enthalpy of 3001.9 kilojoules per kilogram. Find the temperature of the specific volume and internal energy. Given are these. The pressure is equals to 140 bar, or we can convert in kilopascal, 14,000 kilopascal. So the enthalpy is in 3001.9 kilojoules per kilogram. So for the temperature in based on the superheated table at 140 bar, the enthalpy of 3001.9 kilojoules per kilogram at the temperature is at 400 degrees Celsius. So for specific volume based on the table, the volume is equals to 0.01722 cubic meters per kilogram. So we can now solve for the specific internal energy. So internal energy is equals to enthalpy minus pressure times volume. So substitute the given formulas. So given values. So 3001.9 minus 1400 times 0.1722 parentheses. So the internal energy would be 2760.82 kilojoules per kilogram. Thank you, sir. That's all for me.